This video is going to look at angles in regular polygons. Now, in polygons, first of all, a polygon, you should know what that means, and it just means it's a shape made up of straight sides. So, for example, a circle would not be a polygon because there's no straight sides. But this one here, where you've got 6 straight sides joined together, this would be an example of a polygon, and it is a hexagon. Now, the angles in a polygon, you have 2 types. You have interior angles and exterior angles. So obviously interior are going to be inside the shape. So that would be one interior angle, and obviously if it's a hexagon, then we're going to have 6 of those. If it's a regular polygon, that means that the sides are all exactly the same length, and therefore the angles are all going to be exactly the same as well. So those are the interior angles, and if you extend the line for each of the sides like this, you also have what are called the exterior angles. So this one here would be an exterior angle, and so with this one, and this one, and this one, this one, and this one. Okay, so the exterior angles always add up to 360 degrees. It doesn't matter what kind of polygon it is, whether it's a pentagon, a hexagon. If you've gone all the way around the edge like that, it's going to do a complete turn. So it's 360 degrees. So quite often it's a lot easier with polygon problems to think about the exterior angles rather than the interior ones, because they will add up to different amounts. So exterior angles always add up to 360. Okay, so we're going to use that fact to work out exterior angles. And the other thing to point out is that, remember, if you know the exterior angle here, you could work out the interior one here, because these are angles on a straight line, aren't they? So you could just do 180, take away the exterior angle that you work out, and then that would give you the interior one. So if we have a look at some problems in just a second, just before we do that, if we were going to work out, for example, the exterior angles for the hexagon, if we know they add up to 360, we would do 360 divided by 6, because there's 6 of them, so each one would be 60 degrees, and therefore the interior one, if we do 180, take away the 60, the interior one must be 120. So I personally think, if you're having questions with regular polygons, which they tend to be in the exam, to, even if the question's asking for the interior angle, work out the exterior one and then just take it away from 180. So these are different types of questions that they could ask in the exam. So the first one is telling you that each exterior angle is 30 degrees. Work out the number of sides of the polygon. So we know that the exterior angles add up to 360. So all we need to do is see how many 30s make 360. So that's going to be a division, isn't it? So 360 divided by 30, and the answer is 12. So if there's 12 exterior angles, then there must be 12 sides as well. The next one, we need to work out the size of the exterior angle of a regular hexagon. So that's exactly what we just did a minute ago, but I will just talk you through it one more time. So in the exam you would think, right, exterior angles add up to 360. It's regular, so therefore they're all going to be the same. A hexagon has 6 sides, so I remember that because 6 has got an X in it, like hexagon. So a hexagon's got 6 sides, so we just need to do 360 divided by 6, which is 60 degrees. Right, the next one, if this came up in the exam, this is where you might start to think, oh, I don't know about interior ones. So, because this is working out the size of each interior angle of a regular octagon. So remembering the fact that if we extend these, the exterior and the interior ones would add up to 180. So let's work out the exterior one first. So that's going to be 360, because they always add up to 360. An octagon is like an octopus, it's got 8 sides. So I'm going to divide that by 8. So 360 divided by 8 is 45 degrees. So that means this one here is 45. And I need to work out this one here, so I just need to do 180, take away 45, which is 135 degrees. Right, the final question I'm just going to show you, these tend to come up in the exams quite a lot. So we've got a regular hexagon and a regular octagon, and we need to work out the size of this angle here. Now, again, it's just personal preference. I find it easier to keep this line going like this and work out the exterior angle here for the hexagon and work out the exterior angle here for the octagon, and then you can just add them together to get the whole thing. So for a hexagon, it would just be 360 divided by 6, which we did earlier, which was 60. So we know that this angle here is now 60. And now we need to work out this one, and it's an octagon, so it would be 360 divided by 8, which we also did earlier, was 45 degrees. So to get the whole thing, we're just going to add them up, so 60 plus 45, so it would be 105 degrees.